In this video we're going to work out the volume underneath this given surface, within this region. So there's some sort of region down here. So this is the origin here. There's some sort of region down here which we don't know what it looks like, and we're trying to work out the volume underneath this surface. Okay. First step, we need to understand the region. We need to understand what our region looks like. So looking at the inner integral, the first one will be dx. So that would mean it would be x equals something, and then the outer integral would mean it's y equals something. So so let's look at this thing here. What does this whole region look like? Well, let's zoom into this bit here. Rearrange, square both sides, so that would be like x squared equals 1 minus y squared, and then add y squared to both sides. So here you know it's some sort of circle. This is some sort of circle, and then, well, it turns out that the origin's here. So this is your x-axis. That's your x-axis. This is your y-axis, and we are talking about a circle. Well, this here, hang on. So this here would be your positive strand, and then you've got your negative here. So this would be your negative strand, and you know it's a circle of radius 1. So this would be 1. This would be 1. And then if you look at dy means you're scanning from y equals -1. So remember, this is the y-axis. You're scanning from -1 to +1. So really the region that we're interested in is a circle of radius 1. So we need to convert this into polar form, because look, x squared plus y squared. So when you convert it to polar form, it would just be r squared. But when you convert it into polar form, it would be you integrating like this. The radius will always be 1, and you're scanning from an angle of 0 to an angle of 2 pi. So you're scanning like this. Hang on, you're scanning like this. The radius is always 1. Okay, so let's convert this into polar form. So in polar form, v equals double integral, and then we've already seen why this is the case. When you convert it to polar form, it would be r dr d theta, and then always keep an eye out for x squared plus y squared. That would be natural log r squared plus 1, because this thing here is r squared, and we've seen y many times in the past. And then the inner integral would be r. So we need r equals something. The outer integral would be theta equals something. And remember, it's a circle of radius 1. So it's a circle of radius 1. So we're looking at a radius of 0 to a radius of 1. Radius of 0 to a radius of 1. Radius of 0 to a radius of 1. So we're integrating from a radius of 0 to a radius of 1. And we're scanning from an angle of 0 all the way around here. So that would be from 0 to 2 pi. So converting this into polar form will then give us this thing here. So that would then give us this thing here. So now it's just a matter of integrating this. So integrating this, use substitution. So let u equals this thing here. So that means du equals 2r dr. So this thing here would be u. This r here is this thing here, and this dr here, well, rearranges to make dr the subject. So that would be du over 2r equals dr. That's right. So now we can put this into here, which will then give us this thing here, and then the two r's, they will cancel each other out, and then leaving you with this half here. Well, you can take the half out, so that will then give us this half here. Well, this whole ugly thing here will then become this thing here. Okay, and we need to sort out our limit of integration. So you making this substitution would be the same as you integrating from u equals 0. U equals, when you put 0 into here, it would be 1. So you're integrating from u equals 1, and then put 1 into here. So that's the same as you integrating from u. That would be the same as u equals 2. U equals 2. So you're integrating from 1 to 2 in the u realm. Okay. Well, anyway, this whole thing here will then become this thing here. So now it's just hang on. Sorry, we are currently here now. We are currently here. So now it's just a matter of integrating this. It's just a matter of integrating this. So hang on. So it's just a matter of integrating this. So now we've got to use. Remember, in back in calculus 2, we would integrate natural log of x dx, and in order to do this, we would use integration by parts. So for you to integrate this, imagine it as 1 times natural log of u, and then integrating by parts. We've done this before, so it's blah blah blah. If you integrate this, it will give you this, and we've already seen this in calculus 2. So when you integrate this, it will then give you this, from 1 to 2, from 1 to 2. So now we are currently here. Okay, so hang on, and then now put 2 into here and into here. That will then give you this, and also put it into here. That will then give you this, and then you take away and put 1 into here. Natural log of 1 is 0, so this whole thing here will be 0, and then put it into here. It will give you -1. So when you take away a -1, it will give you a +1. So that will then take us to here. Don't forget, hang on, don't forget, we can actually take this half out here as well. So bear that in mind. So we are now currently here with a half on the outside. Okay, so now let me think. Single number, merge them together. That will then give you this. So now remember, this whole thing here is a constant. So when you integrate it with respect to theta, it will be a constant theta from 0 to 2 pi, from 0 to 2 pi. Well, put this into here, blah blah blah. Your final answer would be this. Okay.